Hi, welcome to your exponent and logarithm gateway test from your summer assignment solutions video. Take a look at your exponent and log properties that you should remember from your pre-calculus and algebra 2 classes. Taking a look at number 1 first, this is playing on the property that the natural log and e to a power are inverses of each other, and so they cancel each other out. So this essentially goes to 7x equals 15. So our final answer, x equals 15/7. And then we're done with the problem. So super easy. Over here, we're playing on the fact that we would like for you to recognize your exponent rules. Yes, I could just start cross multiplying, but I see that I have this e to the x plus 5, and then I have e to the 5th here. What we want you to recognize is that e to the x plus 5 is the same as e to the x times e to the 5th. That when you are adding your exponents, you're actually multiplying like bases. So when you take a look at this, now I can cancel these two out and end up at e to the x equals 3. Then take the log of both sides. So we would have the natural log of e to the x equals the natural log of 3, or x equals natural log of 3, because these are going to cancel out. Now, coming down to number 2, our property that we're looking at in number 2 is understanding that in this case we would multiply, and in this case we would add. So it becomes e to the 6x equals e to the 3 plus 2x. Then we take the log of both sides, the natural log, and if we are utilizing the inverse property, then they would cancel the e's out. Or you can just recognize at this step that if it's e to stuff equals e to the stuff, you can go straight to 6x equals 3 plus 2x. That's basically called the one-to-one property, that if the outputs are equal for a one-to-one function, then so are the inputs. But you're essentially just taking the natural log of both sides and canceling. So this would end up being 4x equals 3, or x equals 3/4. And we're done with that problem, practicing our properties. All right, over here in number 4, what we're looking at in number 4 is this idea that there are properties of logarithms. And what we want to do is we want to be able to simplify what's here before we start doing anything else. So we want to take what's written there and combine that together using our log properties. Numbers in front become powers, and when you subtract, you divide. So this problem ends up becoming e to the 1 natural log of x squared in the top, and then in the bottom we have the x squared plus x minus 3. Of course, that's equal to 1. So we highlight and we take that entire exponent and we rewrite it so that it is one single logarithm using our log properties. Then we can cancel, because these are inverses of each other. So we end up getting basically x squared over x squared plus x minus 3 is 1, and then we just use our algebra to solve. Essentially, we would end up with x squared equal to x squared plus x minus 3. Cancel your x squareds. So x equals 3 would be our solution to that one. All right, over here, what we're looking at is this idea that we are quadratic in form. So if you look at this, I'm just going to do a little rewriting using the exponent properties. This is the same as saying 3 to the x squared. So that first term is a square term. Then here in the middle term, this is actually 3 to the x times, I'll write it right above, 3 to the x times 3 to the 5th. Okay, 3 to the x, 3 to the 5th. Now, I'm going to leave it like that instead of multiplying it out, because I'm going to change the order though and make it 2 times 3 to the 5th times 3 to the x. And your quote unquote variable in this problem that's going to be quadratic is this 3 to the x, and then here's your 3 to the x. That's your quadratic form. And then plus, and then this right here, I'm going to recognize that 3 to the 10th is the same as 3 to the 5th squared equal to 0. And if you look at this and you see, well, it's clearly a quadratic. You have a variable squared minus numbers times the variable plus a constant. And then what I want you to recognize is this is actually a perfect square trinomial, that you have essentially a squared minus 2 times b times a plus b squared. Let me fix my board, it's messing up a little bit. B squared. And they equal to 0. So this is essentially a perfect square trinomial that factors nicely, which factors to a minus b squared equal to 0. So thinking of a as 3 to the x, b as 3 to the 5th, we know that this then factors to 3 to the x minus 3 to the 5th squared equals 0, which is going to give me factor 0 product property. 3 to the x minus 3 to the 5th equals 0, so therefore 3 to the x equals 3 to the 5th, and x is 5. So it's a little bit that you have to recognize that this is a quadratic in form, and that it's actually even nicer than just being quadratic in form. It is a perfect square trinomial. All right, sketching graphs. This is just, hey, you have a parent graph. Please know what they look like. E to the x has a horizontal asymptote on the x-axis and is simply exponential growth. And so it comes in, comes across, and grows exponentially. So fairly straightforward. Just know what the parent graph is. All right, and number 7, we're looking for the x-intercept of this graph. And we remind ourselves to find x-intercepts, we let y equal 0. So we get ln of x plus 2, and then we're just solving a log equation. Subtract your 2. That equals the natural log of x. Apply the e function. I need to solve for x. I have a natural log. The inverse of the natural log is the base e exponential, so I apply the base e to both sides. So that way I can cancel over here, and we get a final answer of x equals e to the negative 2, or 1 over e squared. All right, taking a look here at our properties, we're just practicing expanding. And so remember that when you multiply, you'll add logarithms. When you divide, you will subtract. And when you have a power, and this square root is a power of 1/2, you can pull the power to the front. And I like to do it all in one step. We do want to, just kind of get used to working with these. So I would do, running through this, the natural log of the 4x to the 5th minus x minus 1 plus, bring your square root out as a 1/2 power, natural log of your x minus 7, and then pull out you're going to subtract now because this is in the bottom, and that's a power 3. So pull your power out and then do natural log of x squared plus 1. And so you've expanded it by utilizing the 3 properties. All right, and number 9, solving for x. Whenever you are solving and you have logs, if you have more than one log, you are going to need to get them together using the properties. So I'm going to first apply the property that subtraction is division. And so we would have x over x plus 1 equals 1. So I use the log property. Then you are going to apply your base e exponential to both sides to get rid of this natural log. Sometimes I just come in and write it right below like that because I know that I'm going to do it. Cancels over here. So x over x plus 1 is going to equal e to the first, or e. And then I would go ahead and I would cross multiply ex plus e. This is just a number, so distribute it. Put your x's together. X minus e to the x equals e, or e times x. That would be a little bit of a mistake right there. So e times x, factor your x out, 1 minus e equals e, x equals e over 1 minus e. All right, and our last problem is find the domain of the function, which is the log. You cannot take the log of 0 or a negative. So what's inside has to be greater than 0. So x would have to be greater than negative 2/3. So our domain, negative 2/3 to infinity. All right, so there's our gateway test for exponents and logs.